Model explanation in machine learning are important to inform critical decision to some of the critical domains like finance, banking, medicine, criminal justice. So we have many more domains where model explanation plays a very important role. For example, you applied for a loan and the bank software which runs machine learning at the background has rejected your loan application. And now as a customer, you have asked bank to explain why they have rejected your loan application form. And company has provided a proper explanation about why your loan has been rejected. But in many cases, that's not sufficient for customer. And customer would like to know what additional changes they will make in their loan application form so that the chances of getting loan next time would be improved. So we'll take one concrete example to understand what it means. So take again the loan application form, and I have applied and it has been rejected. So that's the class I have been assigned, loan rejected class. And the dotted line represents the machine learning model boundary. And in the left side, it categorized as loan rejected class. And on the right side, it categorized the loan as loan approved class. And here is my input data. So that's my original input data. And what we are asking the counterfactual model interpretation to provide me a set of counterfactual examples so that my input would be modified a little bit. And whenever I will apply my loan application form with those modified input, it would be approved next time. Okay, so take the first counterfactual example. So it says increase income by 10,000. So once that will happen, my loan application form would be approved. Now we'll take the second counterfactual explanation. It says that increase income by 5,000 and have one more year of credit history. So once I would be able to meet those criteria, my loan application form would be approved. And that's the purpose of counterfactual explanation. And that gives a good indication to customers to understand what changes they need to make in their profile so that their application form would be approved next time, whenever they will apply loan next time. Okay. And in this video, I would be talking about telecom churn data. And in that churn data, I will try to find out the important attributes of customer telecom uses, right? So that company could develop focused customer retention policy to retain customers. And we'll try to see what are those important attributes the telecom company needs to focus on so that they can minimize the churn rate. Okay. So you can find out the table description, which contains all the data attributes and their description, right? So which contains details around the customers, contains details around what are the services customer are using, customer account information, and demographics. And we'll use all those information to generate counterfactual explanation with the help of DICE package. So this is the package which has been developed by Microsoft. So you can go through this GitHub link, and also it contains a very good documentation, right? So first just install it, DICE-ML, and once it would be installed, we'll simply get the data. So I am taking telecom customer churn data from my Google Drive. I will just get it pulled from my Google Drive. And once that is done, you can see telecom customer churn data. And in this video, I will be training one simple artificial neural network with the help of Tensorflow Keras. And then we'll take those models to generate counterfactual explanation with the help of DICE-ML package. Okay, so I have imported all the packages, and you can see that this is the important package, import DICE-ML, right? Because all these stuffs are as usual. I have imported TensorFlow package, and I have imported some of the important functions which I would be using. Okay, so I'm just simply loading data. I will explain it. Okay, so that is done. You can see the distribution of yes, no, how many customer has churned and how many customer hasn't, right? So those sort of details. And now the next step, we need to prepare data so that dice ML package, which will generate the counterfactual explanation, can process the data and provide a good set of counterfactual explanation to us. So here I am simply providing some exclusion features. So customer ID, which are unique. So I'm not using those value for training. And I'm also removing the total charge field. So that's the first step. The second step, I am defining the target column. So target column is churn. So you can see this example. This is target column. So I'm simply taking that data and I'm converting it to 0 and 1. Okay. And next I am finding out all the numerical column with the help of this, finding out all the categorical column with the help of this. And from the numerical column list, I am excluding these features because I don't want to use these features for my model training. So that's what I'm doing it here. I'm preparing a numerical feature list which will not include any features which exist within this list. Right? And similarly for the categorical column also. And then finally, I am just combining numerical and categorical features to prepare the final list of features. Okay. And next, I am simply extracting all the values which have these features. Okay, so that's done. So this is the pre-processing step we have done. And now we are using dice ML package data to prepare data in dice ML format, right? Because dice ML internally use data in appropriate format, and this utility will provide us to pre-process data in the correct format, right? So here I'm providing the data which we have used here, right? And I'm providing the continuous feature list explicitly. So here I'm giving monthly charge because most of the columns values are categorical, right? So that's what I'm doing it here. Provide all the numerical features explicitly under this value, right? And outcome name is churn. So that's it. That's the only thing we need to provide. The other thing we need to do, we need to split this data between training and validation. And this split data, again provided by the dice ML package, will split data between train and valid, right? So again, it has some parameter to normalize data and convert all the data in the one hot encoded format, right? So these are the inbuilt functionality provided by dice ML package, which is very handy. We don't need to go through all those steps to convert data in one hot encoded and provide a scaling or provide a normalization for the numeric features, right? So these are very handy. So next, what we will do, we will simply take training data, and from training data, we don't need to include the target column, and that's what we are doing it here. Xtrain merge will contain all the training features, and ytrain will have only my target column, which is my churn data. And similarly for the X validation merged, right? So which will have validation data, and this contains my target column, right? So we'll run it, right? And now you can see that it will have 117 column. So initially we had close to 21 features, and now it has been one hot encoded, right? And you can see that monthly charge value has been scaled, right? So that's from the data preparation perspective, right? And now probably we can start writing small TensorFlow network, right? So here I have written a 2-layer artificial neural network, right? So before starting this, we need to initialize all the random seeds so that we would be able to reproduce our results, right? So here I'm simply importing seed and initializing it with 1. and from TensorFlow random I am importing set seed. So these two are very important. Otherwise, you will not be able to reproduce your test result, and it will vary every time you will run this program. It's a very simple artificial neural network which has two dense layer, right? One contains 1024 and the other also contains 1024, and in between we have a dropout of 0.2. And finally, the final layer is simple dense one to get the desired output, right? And we will compile this with the help of binary cross entropy, right? An optimizer I am using Adam, and here I am tracking accuracy and AUC as a part of metrics, right? So that's it from the artificial neural network perspective, right? So that is done. Now what I will do, I will simply train a model, and here I am defining the early stopping criteria. So my early stopping criteria, I have defined it here like this. Patience is 5, so it will wait for 5 epoch, right? And if it will not see improvement, it will stop. Checkpointing, I will be storing the best model weight in this file. So that's what I have defined it here. Checkpointing, say best only, which is true. And then I am here defining reduce learning rate on plateau. And for that, it would be monitoring validation loss, and it would be reduced by factor of 0.2. Okay. So it would be reduced till this point. That's it. So these are the callbacks which I am defining it. So all are inbuilt within the Keras, TensorFlow Keras, and I am simply using it to configure our model training pipeline. So here I am defining model.fit, model, whatever we have trained, defined it here, will start training activity. So it will model.fit, will use the training data which we had created initially. We are passing the target value. Epoch I have defined is 100. Okay, validation, here I am defining validation data, and here I am defining the callbacks, right? All the 3 callbacks which we have defined here. Okay, and the batch size I am defining 64. So once you will run it, it will take some time. So I'm not, or probably what I can do, I can just run it for 25 epoch, and then probably I will explain the other part of the notebook just to, or probably I will simply run it for 50 times. It will be very fast. It will not take much time. And what I will do, once it's happening, I will continue to do the other parts. And here you can see it. It's saving the model weight in here, and you can see that validation AOC and validation accuracy. It would be improved on iteration basis. You can see it, right? And at every iteration, it would be saved in this file, model weight HD5 file, right? Once it will be trained, we will take that model and will try to generate model explanation with the help of DiceML package, right? So once it will be complete, what I will do, I will load the weight of the trained model, okay? And I will configure the backend. So backend in this case would be TensorFlow, and whatever version it would have, it would take it as it is, right? And now it will prepare the DiceML artifact with the help of this DiceML.model, and we would be passing the model weight. So whatever model weight we would be loading as a part of this function, it will load that weight, and here I will configure the backend. Okay. So once that would be done, we'll initialize the dice ML. So with the help of dice ML.dice, and we'll be passing argument as D. So D is the data set which we had initially created. So I will just show you what we had created. So this one, okay, and I'll be passing the model. Okay, so that's what this step is doing. It will take everything and it will create an explainer, and with the help of that explainer, it will try to generate counterfactual explanation, right? So that is done. You can see that that is done. So we'll simply run it. Okay, that is done. And now what I will do, I will take one query instance. So in this case, I am just taking one query instance. So we need to pass all the input value as it is in this JSON layout. And now we are asking to generate different counterfactual explanation. So this is for the churn data. So in this case, I am providing the query instance for the customer who has been churned, right, based on historical data. And now we'll ask model explainer to generate different counterfactual explanation so that my customer will not churn, right? And we'll see what changes it's recommending us to make in the input value. Okay. So we'll simply run it. And here I'm saying that generate counterfactuals. It will take this query instance. So here like this, it will take the original input. That's what we are giving it here. It will take the query instance. And here we are saying that total underscore CF. Generate 4 different counterfactual explanation. Right. So here you can see that it has generated 2 counterfactual explanation. And here we are saying that generate 4 counterfactual explanation. And the desired class would be opposite, which means that whatever outcome it will have, just take the other one, right? So the original class was rejected and I would like to generate counterfactual explanation for the approved class. So that's the meaning of opposite. And here for the visualization of the counterfactual explanation. So we'll simply run it and now we'll see what it gives. So it will take some time to generate all the counterfactual explanation, and once it would be generated, we will review the content of those. I'm just pausing it until it. And now you can see that it has generated some counterfactual explanation, right? So here you can see that original outcome was 1. That means my loan, this customer initially was churned, but here after making these changes, my customer will not churn, and we'll see what changes they are recommending, right? We'll simply review it and we'll try to see the possibility whether it's possible to make those changes for a given customer or not, right? Because it's simply a counterfactual explanation based on the data it has seen, right? And as a user, we need to assess the viability of those explanation, right? So we'll see first counterfactual explanation, and here it's recommending to change the gender from male, so which is not correct. I mean, that's not possible. We cannot change the gender. So that's a absolutely not a valid explanation for us. So we'll cut this. Not possible. The second explanation, it's saying to make changes in the tenure from 2 to 63, and it's recommending some changes in the monthly charges. So that is doable, but not perfect. And it's saying that modify dependent no to yes. So again, we cannot control the dependents, right? So sometimes it's possible and sometimes it is not possible. So we cannot rely on these factors. So again, this does not look like a valid counterfactual explanation. In the third, again, it's recommending to make changes in the tenure and monthly charges. And next, it's saying that streaming movie, yes. So it's doable, but not perfect, right? And that's what we need to review as a part of assessment. So whatever counterfactual explanation this package will provide, we'll need to review it. And if it does not look like obvious, probably then we need to tweak some of the parameter which dice package provides. right? So we'll see it. So now we have two parameters, which is proximity and diversity. So proximity means we need to generate counterfactual explanation which will match the initial profile of the customer. And the counterfactual explanation should not deviate too much, right? Because here, if my gender is male, it should not be changed to female because it's deviating from the customer profile. So that's the meaning of proximity. Diversity means we also need to provide a variation of different values, right? So that will not too much focus on the profile, but also we need to explore the other areas where it's possible to make certain changes, right? And that's the trade-off we have. We need to maintain between proximity and diversity. And we have two parameters called proximity weight and diversity, right? So by default, the proximity weight is 0.25 and diversity weight default value is 1. And here I'm simply increasing the proximity weight from 0.5 to 1.5 because we have seen that it's not following the initial profile of the customer who would have churned, right? So we'll see it. And once I will run it, we'll see what changes it provides. And now you can see that it has generated some counterfactual explanation. And this time it looks slightly better because this time it's not modifying the value of gender, right? So initially we had male and it has retained those value and hasn't modified in my counterfactual explanation. But this time it's saying that increase the tenure rate and monthly charges rate. And again for monthly charges rate, you can see that it has tried to maintain the consistency. Initially it had 53.85 and now you can see that at least for these two rows the value is pretty much close. And for these two, for this it has been reduced and for this it has been increased, right? So those sort of variation it has not provided, right? And so you can see the possibility which explanation looks good from your perspective, right? And here it's saying that for this record the probability of customer will churn is 99.99 and here it's saying that probability of churning is 0, right? So once you'd be able to modify these values in your input data, the customer will not churn. But again, you're not happy with the explanation which they have provided, the DICE package has provided. And I don't want to modify the tenure rate and monthly charge rate, right? I just need to vary certain fields so that we can see that what changes we need to make on those factors so that my customer will not churn. And that's the third point I was talking about. We'll only select few features which will vary, right? So here in this example, we have 26 fields and I don't want to modify all fields. I would like to focus only on these fields, which are internet service, contract, tech support, monthly charges and payment method. I only need to focus on these fields based on your domain knowledge. We have identified these are the critical fields and I would like to see what variation I would like to make in these values so that customer will not churn, right? So that's the point I would be talking about here. So we'll simply run it and now we'll see what it provides. And now you can see that it has provided 4 explanation and in that explanation they have only modified these fields which we have specified here. So you can see that the variation in monthly charges, we have seen some variation in the internet service, right? So these are some valid combination which counterfactual explanation has given. And again, we need to assess these values, whether these values are viable from our business perspective or not, right? But now it's look like it's viable, right? Because here it's recommending to reduce the monthly charges and for some it's saying to increase the monthly charges, right? It's like 61 and 118. And it's also saying that it's providing some recommendation for internet services, right? So using fiber optics. So like this, it has provided some recommendation. But again, I'm not happy with the explanation because I don't want to modify my monthly charges. I would like to keep my monthly charges as it is, right? Because as a customer, I don't want to increase my monthly expenses, right? So that's what I will do next, and will try to see what model explanation or alternatives counterfactual explanation gives. Right. So here I am removing the monthly charges from my feature to change, and only these four values would be changed. Right. And then we'll review the explanation again. Okay. So we'll run it. And now you can see that the counterfactual explanation does not include any variation of monthly charge amount, because that's what we had done. We have removed the monthly charge from my feature to vary column, and that's why it hasn't shown any variation of monthly charge amount, right? So if we review the possible explanation, it contains only different variations of internet service, tech support, contract, and payment method. Okay. So if we review some of the explanation provided by DICE package, it says that if we'll migrate internet service from DSL to fiber optics, and if we'll provide tech support as no internet service option, and payment method from mail check to credit card, then probably this will allow us to retain that customer, right? So that's one option. The other option could be the fourth one, where it's recommending that provide tech support to the customer and increase the contract from month to month to 2 years. Then that will allow you to avoid any churn. Okay. So based on your requirement, based on whatever business processes you have, and based on profitability and all the other different factors, you can decide which options are more suitable for your business. And based on that, you can optimize your marketing plan, or you can optimize your customer retention policy, right? And these would be very handy tool for explaining any model output and how we can make a change to the input feature so that customer will not churn. Right? So that's it for now. Thanks for watching it.